Okay, girls, so I'm just going to show you the video for these preparation of copper 2 sulfate, right? So now see, girls, here, this is the most favorite, you can say the salt preparation, like from examiner side, and they're just going to, check, they do ask what will observe when you're going to add excess of like metal oxide. Okay? Now see, to make copper 2 sulfate, you're using excess of copper 2 oxide in dilute warm sulfuric acid. Right? So
That's sulfuric acid. This then needs to be heated to 50 degrees in a water bath.
I hope it is.
We will then add an excess amount of copper.
Now see, we are using warm acid, right? Then we are going to add excess of this copper 2 oxide
to the acid mixture. We add an excess amount of copper
now
oxide
see,
to it.
how do you, now there will be no there are not going to be bubbles because salt and water is being formed, right? Now as soon as you're adding excess or copper 2 oxide, there will be solution is turning blue, right? Hannah. So because copper 2 sulfate is being formed, see?
We then return the mixture to the water bath to allow for the reaction to occur. The reaction
now
is
see,
complete when the
how are you going to know that you have added how are you going to know that you have added excess? Like there will be no more color change. Okay?
Blue. At this point, we need to remove the unreacted copper oxide, which appears as a black residue. We do this using filtration. The excess water produced by the reaction.
Now see, you are going to transfer the filtrate in an evaporating basin, and then you have to heat.
Is removed using an evaporating dish and a Bunsen burner. When only a small amount.
See, this is going to be the saturated solution. When
the solution remains, this can
you're
be
just going to allow it to cool.
a petri dish and left to evaporate naturally overnight.
See,
this will leave you with
these are the crystals of copper 2 sulfate.
Pure crystals of copper sulfate.
Right, girls? Did you get it?
Can you stop moving? Yes.
Okay, I have to show one more video, but that was supposed to be my most favorite. That's going to be more, easier to know that although that's going to be the
can give you an
older one. Give me a second, I'll show you. But the basic, again, the points are going to be the same, that you're adding excess of this one. Now see, girls, this is going to be warm dilute sulfuric acid, okay?
Copper oxide.
Now they're going to add excess of
containing some dilute sulfuric acid, and this needs to be heated. The reaction is far too slow at room temperature.
Now see, we keep on adding excess.
You can start adding copper oxide a bit at a time. You'll see that the cloudy solution soon goes a clear blue. The bubbles.
So how do you know that copper 2 sulfate starts to form? There will be the solution will turn blue. Okay?
You can see simply from the boiling, there's no gas given off here.
Right, and how do you know that you have added excess? There will be no more.
Careful not to add too much at a time.
Like see, all acid, like all solid is used up. Okay, means you have not added excess.
It can flop over.
Right, so
keep on adding small amounts of the copper oxide until the solution no longer goes blue and some copper oxide remains undissolved.
Right, so how do you know that you have added excess? There will be no solution change of the color, right? No more turning, the solution is not turning blue. And also there will be insoluble solid is left. Okay, that is going to be insoluble solid, that is black solid of copper 2 oxide, right?
That way you can be sure that all the acid has been used up.
Right, then you are going to filter the solution.
Let your beaker cool enough to handle and then filter the mixture.
So in the residue, there is going to be a copper 2 oxide, and the filtrate we have copper 2 sulfate solution, right? Then you need to transfer that filtrate in
you will see that you have
dish.
A clear blue solution of copper sulfate and black copper oxide remains in the filter paper. If you have the time, you can simply leave the solution at room temperature to allow the water to evaporate. We're going to speed things up by heating it though. Put the solution into an evaporating dish and heat at a gentle boil. You don't want to get it completely dry, as some of the copper sulfate might decompose. But once you
Acha, now see girls, one more thing, as I told you, copper 2 sulfate is a hydrated salt, right? It has a water of crystallization. So you never have to heat those salts till dryness, okay?
start to see some crystals forming, take it off the heat and allow it to cool. You can then
So here are
put
the
it in a warm
crystals of
place to dry properly.
copper 2 sulfate, okay? All right, girls, did you understand?
Yes.
Okay. Any problem? No, should we move further?
Yes, miss.
Okay, I will be solving the past papers of salts with you people so that you will have an idea, okay? Although, one more thing, the last method is going to be titration, okay? As for titration also, girls, I will show you the video and I'll give you the full method because the full method could be asked in paper 6, in which there's going to be 6-marker question, okay? Now see, we are going to make group 1 and ammonium salts by this method, like when you're using a soluble base and an acid, okay? So for example, but when you have to make sodium chloride, so we are going to take a soluble base and alkali. So I'll take sodium hydroxide and we have to take which acid? Which acid for like chloride salt? Girls? Hydrochloric acid. Okay, so salt and water will be formed, right? Similarly, when you're going to have potassium nitrate crystals, so we will be using potassium hydroxide and nitric acid. Okay, so potassium nitrate and water will be formed. I'll be giving you more examples. Let's watch the video and I'll again just start from the scratch. Okay, and please ask if you have any questions. Okay, so I hope that till now, each preparation of salt is clear to you. So preparation of okay, wait. So just watch the video, and this is going to be. This method is known as titration, in which you are going to use a burette and a pipette. Okay, very very important method. Wait, wait. Hmm.
We will explore the technique of preparing a soluble salt using titration.
Okay.
Our first step is to fill the burette with the solution for which we know the concentration of. In this instance, this is the sodium hydroxide. When we read the volume from the burette, we do so from the bottom of the meniscus. We must also ensure that the jet space below the tap of the burette is full with the solution we are using.
So usually, like the solution whose concentration is known is kept in the burette. Okay.
Next, we must measure a controlled volume of the solution for which we do not know the concentration. In this instance, this is the hydrochloric acid. We do so using a volumetric pipette. We carefully place the pipette filler on the top of the pipette. We then evacuate the air and use it to draw 10 centimeters cubed of our solution. This volume is then placed into a conical flask. We use a conical flask because during the titration procedure, we will need to swirl our solution, and this prevents any excess spills.
Right. So why do we use a conical flask? Because you can easily swirl, easily mix. Take it using a conical flask,
We
right?
have finished draining our volumetric pipette. We will touch the surface of the pipette to the solution. This will calibrate the volumetric pipette each time.
And then you have to add 2 to 3 drops
Now-
of an indicator, right? And we are using a white tile so that you can see the color change more clearly. Okay, the indicator could be used as thermophyllene because phenolphthalein is removed from the syllabus as it was carcinogenic, right? Here, over here they're using phenolphthalein, which is colorless in acid and pink in alkali. Okay, and thermolphetylene is going to be also colorless in acid and it's going to be blue in, alkali. Let's see.
Add an appropriate indicator to our solution. In this instance, we have used phenolphthalein. Phenolphthalein appears clear in acid and then turns pink in alkali solutions.
So you have to keep on adding until there will be no more color change, okay? You have to note down the volume.
See this color change more clearly. With swirling, the pink color disappears, but we are looking for the point at which the color just remains pink. When we reach this point, we term it the end point, and we stop the addition of sodium hydroxide from the burette.
Okay, then you have to note down the volume. Now, basically, we are just going to know that what was the volume of alkali which is used to neutralize particular ml of acid, okay? Because salt and water was formed. So, in the next step, what you are going to do, you are going to repeat the same process using the same volumes without using an indicator.
Hydroxide from the burette was added to our solution of hydrochloric acid. Once again, we will read from the bottom of the meniscus, and this will tell us the volume that was needed to neutralize the solution. With this volume to hand, we are now able to repeat the experiment, only this time we will not use the phenolphthalein indicator. Again, we will measure our controlled volume of hydrochloric acid, which in this instance was 10 centimeters cubed.
And without using an indicator, we'll just add
we will then repeat
same volume which was needed to neutralize
from the burette. Okay. Only this time we are well aware of the volume of sodium hydroxide needed.
We are not using an indicator here because it's going to contaminate. Okay,
hydrochloric acid.
Like it's going to act as an impurity over here.
Be aware though that we no longer have the phenolphthalein indicator telling us at which point to stop the addition.
Take it, there was no color change because no indicator was used here. Take it. Do let me know, girls. Is it clear till here? 5 of you, bachcho?
Yes.
Okay. Now, what you will do? We got sodium chloride crystal solutions, right? So we have crystallized
soluble salt. Okay. Our next step is to remove the water so that we are left with the pure salt on its own.
So we are going to do crystallization.
To do this, we set up a Bunsen burner, safety mat, tripod and gauze, together with an evaporating dish containing our sample. We will then place a Bunsen burner underneath the evaporating dish with a roaring flame. The water will then evaporate. We just need to be careful in case the solution starts to spit. We will then be left with our pure salt.
Right, girls? Did you understand?
Yes, miss.
Okay. I am going to write down the whole method because that is going to be helpful in your paper 6, girls. Okay? All right. Acha. So, and then I'll just ask you that if we have to make certain salt, like even ammonium salt, so which acid and which alkali we'll be using. Okay? I'm just going to type it over here so that we can just go on smoothly, right? So we are going to prepare sodium chloride crystals, preparation of sodium chloride crystals. I will be also sharing the links of these videos so that whenever you want to revise, you can do it easily. Okay? And I'll share the past papers. So you could just try, otherwise we could discuss in the next class, right? So you have to pip it out, or you can even start from that, fill the burette. Whatever you watch in the video now that I'm writing, fill the burette with sodium hydroxide. I'm just not writing the name, I'm just using the formula. Aqueous sodium hydroxide or sodium hydroxide solution. Then pip it out 10 centimeter cube or 10 ml of HCl in a conical flask, right? In a conical flask. And then what you have to do, add 2 to 3 drops. Here I'm writing thermolphetylene, okay? 2 to 3 drops of thermolphetylene. Indicator in a flask, right? Achha, bachcho, one more thing now, like we will be doing in paper 6 also in detail. Okay, before adding the volume of sodium hydroxide or addition from the burette, you need to record the initial reading, right? Record initial initial burette reading and start adding NaOH in a flask until you need to definitely tell that how long until the color changes from colorless to blue. Okay? Like we are using thermophyllene, therefore colorless to blue. If we would have used methyl orange, so we could have used red to orange, right? Because methyl orange is going to be just from Roy, is going to be red in acid, is going to be like orange in neutral solution. Okay, and it's going to be yellow in alkali. Okay, so in case of using, like if you would have used them methyl orange, then we could have used until the color changes from red to orange. Okay, then what you have to do is, right, so repeat the same process. After that, what you are going to do from colorless to blue, record the volume, and repeat either with same, you can write down, repeat the same method by using same volumes of acid and an alkali. You can just even specify without using an indicator. Right? Using same volumes, right? Then what you're going to do, transfer the contents. Do let me know if anything is not clear. Transfer the contents from a flask in an evaporating dish. And then you just have to crystallize bachu. Take in an evaporating dish. And then you just have to heat the filtrate gently, heat the solution actually, not the filtrate, gently until it is gently till crystallization point. Okay? Crystallization. Allow it to cool. Right, and dry between the filter paper, right? Is that clear, girls?
Yes, miss.
Okay. This is how you could write, okay? Like for making soluble salt using an alkali and an acid, okay? Like group 1 salt or ammonium salt, okay? You people might take the screenshot of this method, okay? To let me know once you are done with it, okay? Done, girls?
I took a screenshot.
ठीक है. All of you, बेटे?
Yes.
Okay, now we're going to do that. Just let me know, girls, like few practice questions. Like, I have to make beta, suppose, potassium sulfate, right? Which acid should I take?
H2SO4.
Very good. Other than Eliza, rest of you beta try. Which alkali should I take? Alkalis are soluble bases, metal hydroxides, right? So which metal hydroxide should I take? I have to make potassium salt, है ना? So I'll be taking potassium hydroxide. ठीक है? Are you getting Ambreen, Ania, Tuba, Aliza?
Yes, miss. Yes.
ठीक है बेटे? So the products will be potassium sulfate, that's a salt, and water, na? Neutralization reaction. ठीक है? अच्छा, now, do let me know. I have to make sodium nitrate. Can you help me, girls? Which acid and alkali I'll use? Which acid I'll use, Tuba? For nitrate salt, which acid?
Nitric acid.
Very good. Nitric acid. Anya, which alkali should I use? Alkalis are metal hydroxides. ठीक है? I have to make sodium nitrate, so I'll be using what? Sodium hydroxide. ठीक है बेटे? Are you getting it? Anya, did you get
Yes.
it?
Yes.
ठीक है. अच्छा, what? So these are for group 1 salts ना. अच्छा, what about even for lithium sulfate, lithium nitrate? What about ammonium salt? Suppose I have to make ammonium chloride. ठीक है. So aqueous ammonia is also a base, right? And a soluble base and alkali. So I'll be using for ammonium salt, I'll be using ammonium hydroxide. ठीक है. And acid same as chloride. So I'll be using hydrochloric acid. ठीक है. So बच्चों, whenever you have to make ammonium salt, you'll be using ammonium hydroxide. ठीक है. Is that point clear, बेटे?
Yes.
Can you help me in making
Yes.
ammonium salt? Ammonium sulfate salt. What base and what acid I'll use? Again, ammonium salt, है ना? So I will be using what?
Sulfuric acid.
Sulfuric acid. Very good. And ammonium salt है, तो I should be using ammonium hydroxide. Very good. ठीक है?
Ammonium hydroxide.
I have to use ammonium nitrate. I have to make ammonium nitrate. Yeah? So what will I use? Ammonium salt है, तो I'll be using ammonium hydroxide. ठीक है? And which acid will I use? Very nice, nitric acid. बस. बाकी the method is the same that we have used. ठीक है? That we have written. Is that clear? You will just change the starting reagents, right, girls?
Yes, miss.
Okay. I will be sharing paper 4 questions with you. But you try to solve it, and you could ask me if you have any questions, any problem. ठीक है? And few questions that we'll also solve in the next class, inshallah. Okay, girls?
Okay.
I hope you got the preparation of salts, बच्चों.
Yes.
Okay.
Yes.
Amreen, Ania, Tuba, ठीक है? All the best, बेटे. Please ask if you have any questions, okay? Take care.
Okay.
Hafiz.
Allah
Hafiz.
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 Hafiz.